For question number 3, we are given the rate at which water is leaking out of a tank, and we're looking for the total amount of water. Well, what we know about a definite integral is that if we have a derivative of some function, then the definite integral is going to give us the net change in that function. So this is not called a derivative, but it must be. It's a rate of change. It's a rate of change of the total amount of water, right? And the definite integral is the net change. So over the first 2 hours, that's from 0 hours to 2 hours, and we're going to take the antiderivative of, well, whatever r of t is, and we're going to multiply by dt. Again, this is gallons per hour, this is hours, so gallons per hour times hours is going to give us a net change in gallons. And unfortunately, all we know about r is that it is this graph of this function. So if we're looking to shade the region that's going to represent the total amount of water, well, that's really going to be, the question is, what's the area of the region under the curve, right, between 1 and 2? And let's do this. If we're going to give an upper estimate, well, an upper estimate here, I'm going to divide this into some rectangles. And let's see, 1, 2, 3, 4. So I'm going to let delta t be equal to 0.5, arbitrary. You could make it smaller if you want something more accurate, or larger if you don't really care. So if I'm going to create my subintervals, okay, of which I have 4, I'm going to have 0.5. For the upper, I'm going to use a left-hand approximation. So for the first subinterval, my output is 2. For the next subinterval, let's see, this is 1. This is 1.5, I don't know, 1.9. For my next subinterval, okay, so we use 2, we use that. So over here, this is probably, I'm going to say 1.6. For the next one, I have maybe 1.25, and that's where I'm going to stop. 1, 2, 3, 4, left-hand side in each case. So this is going to be my upper. For my lower, I'm just going to use the right-hand side, which happens to be lower. Well, I already have done the work. I know that's 1.9, I know that's 1.6, I know this is 1.25, and my last value is going to be 1. And then we can just find the sum of those.